secretive, slippery customers inhabit our world. Amongst the first vertebrates that ventured from water to land, this group of animals has developed into a colourful family. They change their lifestyle and body shape massively during a single lifetime. They can be harmless or deadly poisonous. Witness the trials and tribulations of the world's animals that spawn to be wild. Frogs and toads are amphibians, a group of animals that live on the boundary between water and land. They're like a staging post between fish and land animals. They're an astonishingly diverse group, with a history reaching back some 230 million years, the descendants of a once dominant group of land animals. Frogs and toads are the most numerous and diverse of the amphibians, with about 4,750 species. They occupy habitats ranging from deserts and savannas to high mountains and tropical rainforests. They can be found almost anywhere in the world, with the exception of the icy poles, salt water and the driest deserts. But about 80% of them live in the tropics. Frogs and toads come in all shapes and sizes, from only a centimetre in length to giants of 35 centimetres that can weigh over 3 kilograms. They can be extremely colourful, from bright blues, greens and reds to fantastically well-camouflaged species mimicking their natural surroundings. Depending on their lifestyle, the body design of frogs and toads can vary enormously. They can be built for a semi-aquatic life near lakes and rivers, designed for hopping on dry ground and among trees, or adapted for burrowing into loose soil. The most obvious features of all frogs and toads are long hind legs, a short body, and the lack of a tail. This body shape allows them to make rapid escapes by unfolding each joint in the hind limbs in a rapid sequence. Put simply, they can jump to safety. Some frogs can leap up to 50 times their own body length. Most have large eyes with good vision. It's a giveaway sign that these animals are predators that locate their food by sight. Their tongue is also highly adapted for hunting. It's attached at the front of the mouth, allowing the killer to flip its tongue out and over the lower jaw to pick up food with its sticky upper surface. All frogs and toads are cold-blooded and rely on the surrounding environment to regulate their body temperature. This can range from only 3 to 36 degrees centigrade. Some have found ways to overcome the problems posed by very low temperatures by releasing glycerol, which acts as an antifreeze in their tissues. The reproductive strategy of amphibians is particularly impressive. First, they lay clusters of eggs or spawn in the water. The eggs hatch into aquatic tadpoles before metamorphosing into adults that can live both on land and in water. It's their ability to exploit both aquatic and terrestrial habitats that has allowed frogs and toads to be an evolutionary success story. An ability to get the best of both worlds has led to an impressive array of breeding methods in vastly different environments. It's early spring in England, and as the first flowers of the year start to appear, other creatures too are beginning to stir. It's the breeding season for common frogs, and they're making their way towards their breeding pools in search of a mate. They gather in large numbers, the males calling out to attract a partner. Many frogs splashing about in the confined space of a single freshwater pool can lead to confusion, and breeding pairs can easily get separated. But the frogs have found a way to avoid losing their mate. The male's hands are specially adapted, allowing him to hold on tightly to the female while she lays her eggs. This ensures that all of them are fertilized by the same male. Most frogs fertilize their eggs outside of the body. The male releases clouds of sperm into the water as the female lays her batches of eggs, several hundred at a time. It's vital that they breed in still water. Any current might sweep sperm and eggs away with it, unfertilized and wasted. The eggs are delicate and lack shells, so must be laid directly in water or in moist places to avoid drying out. Each egg has a gelatinous envelope, which expands in the water, not only to provide protection, but also to increase the surface area, making it easier to absorb oxygen. In real time, the expansion of the eggs takes about 6 hours. Before long, the breeding pond is bursting with clusters of frog spawn. The tadpoles are much more than just a staging post in the development of a frog from egg to adult. They're the ideal way to exploit seasonal food sources that the adults themselves can't eat. In contrast to adult frogs, tadpoles tend to be vegetarians. Rows of rasping teeth grind up and swallow any food they can find in the pool. Some can extract food items as small as 1/10 of a micrometer from the water. That's as efficient as the best mechanical sieve. They're like miniature food processors, little more than a mouth with a massive gut attached and a tail for forward propulsion. Occasionally they even take to scavenging dead bodies, acting as the garbage disposal unit of the pond world. This army of mouths gathers colossal amounts of food as fast as possible. Each tadpole has a single goal: to grow fast enough to complete the metamorphosis to adulthood. The tadpoles develop very quickly, an important adaptation that allows the frogs to breed even in temporary pools. A hormone controls their growth rate. As the tadpole matures, this hormone is released in greater quantities all the time, increasing the growth rate. Even with such impressive statistics, only a small minority of tadpoles actually become froglets. And even some of those drop back into the food chain, devoured by their own kind. Adult frogs and toads have one major advantage over most other animals. They can make their escape from waterborne predators to land, but equally they can return to water to flee danger on dry ground. The two stages of development, tadpole to fully functioning frog, couldn't be more different. While adults find their food on land, they're the product of the tadpole's ability to exploit aquatic food sources. But to ensure success in breeding, all frogs and toads must first find a suitable watery environment to spawn in and let their tadpoles develop. Another traveller is on its way to a springtime gathering. It's a common toad out to find a mate. They come together from hedges and gardens for miles around to spawn in a single body of water. But their journey is often hazardous. Humans have put artificial boundaries in their way that all too often claim the toads' lives. Those that make it safely to the other side and reach their destination first have to go about finding a partner, just like the common frogs. These toads generally lay a lot more eggs than the frogs, as many as 10,000 in a single batch. Such massive numbers suggest that at some time during their development, these young amphibians will fall victim to particularly heavy predation. But initially, the eggs are well protected in their watery home. As with frog spawn, they're covered by a gelatinous membrane. During breeding time, the normally tranquil pond is transformed into a mass of toads seeking mates. Amongst clusters of freshly laid eggs, each toad struggles to create the next generation. Some of the great strongholds of the amphibian world are the tropical jungles of Central and South America, home to millions of tree frogs. Here, water is plentiful, especially during the rainy season when rivers run swift and deep through the forests. But frogs generally breed in standing water to avoid their eggs and tadpoles being swept away or exposed to predators. They've had to develop a different way to reproduce in these forests. They live and breed in the trees themselves. Many of the frogs here are beautifully colourful, with stunning patterns, although many are nocturnal and difficult to find amongst the dense vegetation of the forest. Tree frogs are something special, able to cling to steeply sloping surfaces with their highly adapted feet. Their toes are tipped with enlarged pads that have a specialised outer layer of rough skin, which allows them to cling to any dry surface. But on damp, smooth surfaces, a mucus covering of the toe pads creates adhesion. The eyes of these tree frogs are large and well developed, positioned at the front of the head to allow binocular vision and capable of seeing a wide range of colours. Vision is crucial to detect prey. It also allows them to identify friend and foe. Some of the frogs found in the forests of South America are particularly brightly coloured. They can afford to be. They've developed a defence method unique amongst frogs. They're deadly poisonous and don't need camouflage to protect themselves. In fact, they're so deadly that some South American Indian tribes use the frog's poison to tip arrows used for hunting. But most frogs use camouflage for protection. Some of those living along the boundary between the river and the forest are incredibly hard to spot. During the day, they sit motionless on leaves, waiting for the cover of darkness to go about their business. To be successful, most of the frogs coordinate their breeding to coincide with the beginning of the rainy season. These male olive yellow tree frogs are the first to start calling to their mates, even before the beginning of the rains. Unusually, they become active during the day, openly advertising their positions for a single week of the year. But their drive to reproduce exposes them to danger. As well as receptive females, predators are also on the lookout. Swamp spiders are active hunters here, and the frogs have no defense. For a brief period, they make a tasty seasonal delicacy for the spider. As May turns to June, heavy rain clouds begin to hug the hills, and the rivers swell with rainwater. They become dangerous torrents entirely unsuitable for frog spawn. The trees provide a solution for the frogs. The rain here is so heavy that the leaves of the forest themselves turn into an aquatic environment. This is where the frogs lay their eggs. Even for a tadpole, the rivers and streams are running too fast. But temporary water pools formed on the rainforest floor are ideal. Before they dry out, the adult frogs must lay their eggs quickly. Rich supplies of food can be found in the shallow pools, making them an ideal nursery for the frogs' tadpoles. At night, a chorus of frogs starts to sing. The males are announcing their position and availability to passing females. Each species has a specific call, ranging from the high pitch of a tree frog to the low rumbling of bullfrogs. The most impressive singers will get the best partners. Once the pairs find each other, they begin to mate. There's no time to lose if their precarious breeding strategy is to succeed. This red-eyed tree frog is typical of many others. It lays its eggs in gelatinous clusters stuck to leaves well above the ground. The male is only half the size of the female, and the cluster of eggs she produces is bigger than both of them. Just like most frogs, he fertilizes the eggs externally as the female lays them. You'd think that the fragile eggs would dry out, but the moisture in the humid air and the rainwater running down the leaf are enough to ensure their safety. But even in the trees, it's not an entirely risk-free zone. There are predators here too. This tree snake is quick to take advantage, turning fertile frog eggs into a nutritious seasonal meal. To combat this robbery, the frogs lay their eggs in large batches, too big for the snake to eat in one go. Some, at least, are likely to survive. After spawning, the red-eyed tree frog leaves its eggs to develop on their own. The timing of breeding is crucial, and the fate of the developing tadpoles rests on getting it exactly right. For now, each tadpole is enclosed in its own life support system. Tiny thread-like gills supply life-giving oxygen to the developing embryo. They even have an onboard food supply, a yolk sac supplied by their mother. At this time of year, most tree frogs in the rainforest are busy breeding and spawning as quickly as they can. By now, the leaves of the forest are loaded with eggs, all waiting for the forest floor to be flooded by the rains. The upper eggs in this cluster are a second clutch, a little way behind in their development. Soon, all the tadpoles are ready to hatch. The individual eggs break and come together in a single mass of jelly. Now the reason for the precise timing of the frog spawning becomes clear. They need water below them, but not a rushing river. The tadpoles are designed to take advantage of the brief but abundant food supply on the flooded forest floor. As soon as they can swim, they drop into the temporary pools. Some frogs found in the rainforest show a certain amount of care for their young. This male glass frog is guarding freshly laid eggs. They only have a relatively thin jelly coating at first, so are prone to drying out. The male sticks around for the first couple of days to ensure they're damp at all times. Once the jelly has swollen with moisture, the eggs will be safe on their own, and he can go about his business as usual. It'll all be down to the weather from now on. A heavy shower eventually launches the eggs into the swamp below and into the next stage of the frog's life. The rainwater creates temporary pools rich in food and with relatively few predators or competitors. As a general rule, the more effort spent looking after and guarding young, the smaller the number of eggs produced by the parents. While some frogs lay large batches of eggs and then ignore them, others lay far fewer but put their energy into caring for their tadpoles instead. The poisonous strawberry frog puts a lot of effort into raising its young. The males are very vocal, calling not only to attract mates, but also to ward off any rivals. Each male carefully tries to reserve his own mating area and will defend it fiercely against intruders. Now and again, the frogs fight for a favourable patch of forest. The winner proudly takes his position and gains the attention of a nearby female. The mating of the strawberry frog is a secretive affair. The pair disappears under a leaf, where the female lays only 2 eggs. She leaves the eggs to develop in peace, but returns to collect the newly hatched tadpoles. She carries them on her back to the safety of a bromeliad plant. These plants, dotted around the South American rainforest, are designed to keep a small pool of water in the base of their leaves at all times. A perfect nursery for young tadpoles. It also means that strawberry frogs can breed all year round. They don't depend on temporary pools on the forest floor for their broods to develop. This strategy, however, does have a drawback. Unlike most tadpoles, the strawberry frog's offspring don't share in the abundance of food available during the rainy season. Instead, the mother lays infertile eggs in the bromeliad ponds for the developing tadpoles to eat. She frequently returns to top up their food supply, enabling the tadpoles to stay in the safety of the bromeliad until they've developed into fully formed adults. For most frogs in the forest, it makes good sense to time breeding with the onset of the rains and the time when most food is available. But in other places, it's not only the seasonality of the food supply that's dictated breeding strategies. Some frogs and toads have to battle with much more serious problems. The supply of water itself can be limited. To witness an entirely different breeding strategy based on lack of water, we visit deserts in the southwest of the United States. Given that it's essential for frogs and toads to be near water to reproduce, the desert seems an unlikely place to find them. But even here, at night time in the Arizona desert, there's a toad that has found ways to survive. When the rains come to this part of the world, they have an unexpected effect. As little as 2.5 millimeters of rain, barely enough to encourage plants to grow, raises the spadefoot toad from the sand. Rain is what the toad has been waiting for, and there's no time to lose. Given that water is in such short supply and around for only a limited period of time, spadefoot toads need to time their breeding with perfection. Most tadpoles are designed to take advantage of a temporary food supply, but in the desert, the breeding pools themselves will disappear quickly. It's a race against time. The toads come together at the pools, and a frenzy of mating and spawning ensues. In true toad fashion, the spadefoot toads call to each other to advertise their availability. And competition is fierce. Once a pair has got together, they waste no time before attaching their fertilized eggs to whatever underwater anchor they can find. Usually plants that have themselves been waiting for the return of the rains to this parched landscape. When the adults sense the approach of day and the baking heat of the sun, they call a halt to their breeding efforts and return to the safety of the sand to avoid drying out. During the rainy season, the toads can find relief from the heat of the day just a few centimeters below the ground, where the sand is still moist. Any pools that are formed during the rain showers fill up quickly with spadefoot eggs. Partly because of the warmth of the water, but mainly because these toads have evolved to master the limitations of this harsh environment. The spadefoot eggs develop incredibly quickly. In ideal conditions, tadpoles hatch in less than 48 hours. By the second night after spawning, the tadpoles start to break free. At first, they still have external gills. These gradually disappear during the tadpole's development. Their growth rate is phenomenal, and by the end of day 2, the tadpoles are feeding frantically, scavenging on any organic matter they can find, grazing on tiny algae that grow everywhere during the short wet season. Like the common frog, they produce proportionally more growth hormone as they get bigger. In adverse conditions, they can even produce more of the hormone, pushing the developmental accelerator right to the floor. Theirs is a race against time, against the already dwindling water supply. As a result, they develop from egg to adult about 4 times faster than an average amphibian. But as the tadpoles grow, something strange and sinister happens to some of them. Some undergo a radical change in their nature as their jaws transform from rows of all-purpose rasping teeth to a horny beak. These beaked tadpoles become cannibals, eating their fellow tadpoles. It's nature's way of ensuring that all available food is used before the pools dry out. The cannibals grow quicker than ever. Perhaps they even get an additional spurt of growth hormone from the bodies of their prey. And growing fast is what counts. Their murky desert pools are starting to shrink, and they find themselves in a race against the weather. They only need about 3 weeks to develop into adult toads, but when the rains begin to fail, the situation becomes desperate. The tadpoles can withstand heat, but they can't survive long without water. The hot, dry desert winds evaporate the pools quickly, and the tadpoles become densely packed. During the course of a single day, the pools can transform from a lifeline into a death trap. All that can save them now is a last respite from the weather in the form of a rain shower. Even the ants begin to move in and start to feed on the fat little tadpoles. But against the odds, some of the tadpoles manage to retain a spark of life. The return of the rains gives the survivors a reprieve and the chance to develop fully. Within 2.5 weeks of hatching, the tadpoles have grown their back legs. Soon the front legs will emerge. They're already growing underneath the skin. All the young tadpole has to do is push them through 2 holes in the skin. It's a bit like putting on a pullover. Their jaw bones are also changing shape and grow into the wide mouths of an adult toad. Finally, with its limbs fully grown and the tail getting smaller by the day, the young toad is almost ready to emerge from the water on its first journey onto dry land. Having escaped the dangers of the desert pool, it must now face the challenges of the desert climate. And safety from the heat and dry winds of the Arizona landscape is only to be found underground. The young spadefoot toad will stay here until the rains return and allow it to re-emerge. The toads are very susceptible to dehydration since their skin is extremely permeable, but it's also the key to their survival. Because the skin is so permeable, the toads can efficiently and quickly absorb water from the surrounding soil. It's the same process that plants use to draw water into their roots and is known as osmosis. At first, the toad stores water in its large bladder. As the soil around eventually dries out, it starts to reabsorb water stored in its bladder. Its metabolism also slows right down, and it enters a sort of hibernation until better times return. The Arizona desert is certainly a challenging place for amphibians to live in, but the spade-foot toad is supremely adapted to this harsh environment. It can lose up to 60% of its body fluids, and when fresh water becomes available, it's able to absorb it instantaneously through its permeable skin. It's an extraordinary survivor, making a living in the most unlikely surroundings. There are other strategies to cope with arid conditions. A group of East African tree frogs have waterproof skin, just like most lizards and in stark contrast to the spade-foot toad. Their light skin reflects much of the day's heat and allows them to sit in the sun all day. This is an exceptional strategy. Most frogs and toads have a permeable skin and have found other ways of coping with the hot, dry weather. Take this African bullfrog in Kenya. Like the spadefoot, it creeps into burrows. There it covers itself with a waterproof substance produced from glands in the skin. It stays underground until the rains draw it from its shelter. And the rains are formidable, enough for moisture to seep into the ground and stir the bullfrog into action after its long doze through the dry season. The African bullfrog lives around 40 years, and it spends most of this time underground. Even more amazingly, it can survive up to 7 years in its mucus shell, waiting for the return of the rains. Watch how the frog's waterproof covering begins to blister and peel. It pulls its protective layer off bit by bit. It won't actually be able to go out to feed and mate until the cocoon has been completely removed. First things first, the bullfrog must eat after its long dry season doze, and it eats its own sleeping bag. Although the different strategies amphibians use to survive in dry conditions have little in common, all are designed to maximize use of a very limited water supply and to survive long periods of drought. By conserving water, lowering their metabolic rate during the dry season, and timing their breeding precisely with the onset of the rains, frogs and toads have even managed to conquer the deserts. Around the Great Lakes of North America, another toad has to battle with a very different set of environmental challenges. On the shoreline of Lake Erie, large sand dunes have developed over time, devoid of vegetation and supporting very little life. But the shallow pools that have collected behind the sand dunes on the lake's edge are ideal breeding ponds for Fowler's toads. In May or June, they gather at night to begin a breeding frenzy, calling to each other to locate potential mates. It may seem like a confusing chorus of croaks to us, but the females are very picky when it comes to choosing the right male. They seem to prefer low-frequency calls that might indicate a larger, more attractive male. When they find each other, male and female lock in an embrace and take to the water to spawn. A few days later, the tadpoles have hatched and develop quickly in the warm, shallow water, feeding on remains of plant material washed into the pools from the lake. They feed as fast as they can, cramming their small bodies with as many resources as possible in the short time they have as tadpoles. After 4 weeks, the metamorphosis from tadpole to toadlet is complete, and the young adults are ready to leave the breeding pools for dry land. But it's an extremely hazardous journey. If the conditions aren't right, many will die on the way to shelter. The winds on the lake shore can be very strong and whip up sand that can mummify the little toads on their journey to safety. They don't stand a chance in this weather. Their soft amphibian skin isn't equipped to cope with the hail of dry sand granules. Soon they can't move and eventually dry out and die. The shifting sands on the edge of such a large body of fresh water can be as fatal for young amphibians as the driest of deserts. Lack of water, heat and adverse weather can present serious obstacles for breeding frogs and toads. But what about cold climates and moving water? Even in these conditions in the northwest of America, in a fast-flowing glacial river just above freezing point, frogs have found ways to reproduce and survive. This is Ascaphus, a tailed frog. It's a cold water amphibian descended from a very old line and is one of the most primitive frogs in the world. But it's very successful in this difficult environment. The secret to its success lies in the way it mates. To breed in swift-flowing glacial streams like this one, Ascaphus has had to develop internal fertilization, an extremely rare strategy amongst amphibians. What looks like a tail on the male now reveals its true purpose. It's really an extension of his cloaca, used to transfer sperm to the female without losing any in the surrounding torrent of water. They mate in July, when the water is as warm as it's going to get. Unlike most frogs and toads, there's no mating call or courtship. Ascaphus has no visible eardrums or voice. Instead, the pairs find each other with sight and touch. During the breeding season, the males develop black horny pads on the insides of their legs, and their muscular forearms are enlarged, allowing them to hang on tightly to the females during mating. The female deposits the fertilized eggs in strings under rocks in the stream. The tadpoles that emerge are highly specialized for life in swift running water. Water glides easily over their streamlined bodies, while their lips have developed into suckers, enabling them to hang on to rocks and pebbles. They still have rows of rasping teeth, common to most tadpoles, and live by shaving algae off rocks in the water, slowly creeping forward using their suckers. In the cold water, the tadpoles develop slowly and take between 1 and 4 years to metamorphose. It seems like an age when compared to the fortnight of the spadefoot tadpole's development. Even when the adults emerge, they don't become mature enough to reproduce until they're 7 or 8 years old. At high altitudes and latitudes, where winter temperatures drop drastically, amphibians have to cope with cold, even freezing winter temperatures. Given that frogs and toads can't regulate their own body temperature and take on that of their surroundings, coping with cold is easier said than done. These common frogs in Europe find protected places that they can crawl into for the winter months. Their metabolic rate drops massively. This avoids using up energy reserves too quickly and minimizes the need for oxygen. Even when disturbed, they can hardly move, waiting for the return of spring to wake them from their winter sleep. Frogs and toads are amongst the most ancient of land vertebrates, straddling the boundary between aquatic and terrestrial creatures. They live in a precarious balance with their environment, fine-tuning their breeding and the development of their offspring precisely with seasonal and local conditions. Even the metamorphosis of eggs and tadpoles can take anything from only 48 hours to 4 years, depending on the demands of their surroundings. These are highly specialized survivors, but while being adapted to local climate and habitat can ensure survival in adverse conditions, it can also make them vulnerable. Much of the evolutionary success story of frogs and toads relies on the way they breed. They have the most diverse reproductive strategies of all land vertebrates, each specifically designed for a particular habitat. But each method also requires environmental conditions to be just right for successful breeding. It's a delicate juggling of different factors that must all come together at the right time. But habitats and climates worldwide are changing faster than ever, putting the survival of frogs and toads in serious jeopardy. Deforestation, pollution, and expanding cities mean that amphibians are disappearing at an alarming rate. Their lifestyle and body structure tends to make them extremely vulnerable to chemical pollutants and increased exposure to damaging UV light. But perhaps most important is the fragmentation of their habitats, and especially the loss of breeding sites. The consequences of these losses can be far-reaching. Amphibians are a major part of the terrestrial ecosystem, forming an important link between their prey and predators. They're also what's known as an indicator species. If frogs and toads are thriving, it signals a clean and healthy habitat. Highly adapted species like the frog and toad are the first to suffer when we change the environment. It will be humans that determine whether or not the world's frogs and toads continue to spawn to be wild. Frogs and toads come in all shapes and sizes, from only less than an inch in length to giants of over a foot that can weigh more than 6 pounds. All frogs and toads are cold-blooded and rely on the surrounding environment to regulate their body temperature. This can range from only 37 to 97 degrees Fahrenheit. When the rains come to this part of the world, they have an unexpected effect. Less than an inch of rain, barely enough to encourage plants to grow, raises the spadefoot toad from the sand. During the rainy season, the toads can find relief from the heat of the day just a few inches below the ground, where the sand is still moist.